So question 2 is about the hardware and software. And they say, complete the description for computer memory, random access memory, RAM, and read-only memory, ROM, are both examples of primary memory. Why is primary memory? Because RAM is used for temporary data storage, and ROM is to store the permanent instruction for system. So these two is really important for the system. So that's why it's called primary. Okay, next. Okay, one atom is stored in RAM. Okay, another property for RAM is this is a volatile memory. Why I say so? Because for volatile memory is only store the data. When CPU needs, well, the PC is running. So when the power was turned off, then RAM, the data in RAM will be lost. So it only can keep the data that is running. So the answer is the current running software or data. Okay, for ROM is different as RAM. So for RAM is a volatile memory store. And for ROM is permanent data instruction store. So it's also called non-volatile. So which means the data that's stored in the ROM, even though the system, the power was shut it down, it was off, but the data stored in ROM is still there. So the data like BIOS. So this one is the start up instruction, or we just can say BIOS. Okay, then we have static RAM and dynamic RAM. For SRAM, it stands for static RAM and is way faster and it uses less power, but it's also more expensive. For DRAM, it's much slower, but it's cheap, which is use a cheaper cost to maintain the system memory. Okay, for SRAM, it uses transistor arranged as flip-flops, and which is also called batches. Okay, use another pen. So with these flip-flops, we can hold a bit of data and without flash. So that's one of the reasons that SRAM is faster than DRAM, because for DRAM, you need to flash constantly. Okay. So for DRAM, use transistor and capacitor. And just now we mentioned DRAM is much cheaper than SRAM. One reason because you need to constant refresh, another because the capacitor, the transistor store data in the capacitor and use transistor to access it. And for this capacitor is always leaking the charge. So meaning the memory must be constantly refreshed. Okay, next question. So explain the difference between programmable ROM and erasable programmable ROM. Short form is EEPROM, and electrically erasable program ROM, EEPROM. So here are 4 points. Each point is strengthened progressively downward. Okay, so first we have the difference between PROM, EEPROM, and EEPROM, and then we have EEPROM. EEPROM. Okay, for this we have 3. Okay, let's starting from the first one. Okay, so PROM can be set once, but EEPROM and EEPROM can be written many times. Okay, just now we say EEPROM and EEPROM can be written many times. So that comes for our second point. So since they can be written many times, so EEPROM must entirely erase before rewriting. But EEPROM doesn't have to. Okay, so next point, when EEPROM, we need to remove the EEPROM need to be removed physically from the device to be erased. So have to be physically take out the EEPROM chip, then it can be erased. But for EEPROM, it can be erased when it's still in the device, still in the initial position. It's still in the device. Okay, for the last one, EEPROM, it can be erased by using UV light. And for EEPROM, it can be erased by using voltage. Then you can get 3 points out of the 4, then can get homework. Okay, for this question, it's asking magnetic hard disk is used to store the data in the computer. But the people who don't know magnetic hard disk, let's show you. So we have a spinner, and we have a big plate. This is called platter. And here we have something to point. It's called actuator arm. This small point we call it head, and the one to turn the head is called actuator axis. Here is something surrounded. It's called actuator. Okay, then let's draw a box. So this thing from the magnetic hard disk. Okay, so from here, this question is 5 marks. Then we can write the first one. The hard disk has a platter. This one is the platter. Okay, for a second. So we can see each surface of the platter is capable to be magnetized. That's why I can store the data on it. So we can write this down. Each surface of the platter is capable of being magnetized. Okay, here comes the third point. Since you can see the platter itself mounted on the center of the spindle, so it's put on the spindle, so it's mounted there. So we can list down the platter, or you can call the disc, mounted on the central spindle. And for the disk, we read the data when this to rotate in high speed. So next point, we can say the disk rotate at a high speed. Okay, we just need one more point. And this disk, the movement of this actuator arm is actually controlled by the electronic circuits. So we write it down. Electronic circuit control the movement of the arm. Okay. Yeah, we got all the 5 points. Okay, next is 5 marks. Then we can write the first one. The hard disk has a platter. This one is the platter. Okay, for a second. So we can see each surface of the platter is capable to be magnetized. That's why I can store the data on it. So we can write this down. On the spindle, this contain any zero, the output is always 0. So let's say input will be 1, 0. The output will be 0. So 0, 1, it will still be 0. 0, 0, of course, is 0 as well. Only 1, 1 is equals to 1. So then it's just not plus and. So what will be done here with just opposite. So 1, 0 will be 1. 0, 1 will be 1. 0, 0 will be 1. 1, 1 will be 0. So it's everything inverse from here. Okay, for XR, it will be 1, 0 is always equals to 1, and 0, 1 also equals to 1. 0, 0 always equals to 0, and 1, 1 will be equals to 0. So this is XOR. And NOR, we have 0, 0 equals to 1. So it's actually a net, not plus OR. So for OR, 0, 1 is always a 1. 1 0 is always 1. So 0 0 equals the 0. 1 1 is still a 1. Okay, so no, just a not plus or. So 0 1 equals to 0. 0 1 1 equals to 0. And 1 0 equals to 0. Okay, then we need to see the output we want is all 1. Okay, for NAND, all 1, we need to put 1 1. Okay, for NAND, we want the 0 up to 1. So there's many options. Can just put 0. 0 is good enough. That's true way to do it. And for XOR, we need the answer to be 1. So it's 1 0 0 1. Either way, it could be work. Last one, we have NOR. It's not plus or. We want the only answer is only 1, which is 0 0. Okay, here's question 2. Write logic expression for the given logic circuit. Okay, this is obviously a NAND. So this is the shape of N, and plus a circle, which is called NAND. This is OR. This is XOR. So XOR is put behind, it forms XOR. Okay, for this question, we need to write a logic expression. Can separate into 2 parts. And we focus on A, B first. So A and B, it connect with by NAND. So we just write 8 NAND B. Okay, we're done with this part, so we circle it. And another side, we have B connect with XOR. So B XOR C, so we circle. And in the middle, they connect by OR, so we just write OR inside. So this whole thing, A NAND B OR bracket B XOR C. This is the final answer.